today we're going to be talking about Industry 4.0 and the connected workforce. A little bit about myself. My name is Pete Wassell. I founded Augmate. When I think about the connected workforce and wearables, I probably think about things that a lot of people don't think about. I think about provisioning devices. I think about policies that are set up for Wi-Fi connections, for user management and authority to use those devices, so you're ensuring the right people are using the right devices. There's been a number of notable hacks within the IoT space, and that's something that we're hoping to help avert. Augmate has been implementing this kind of technology for the last 3 years, so we're not a traditional MDM company. We're wearable first and mobile friendly, as opposed to some of the traditional MDMs, which would be mobile first and wearable maybe unfriendly, I'm not sure. And I can say that with some assertiveness because we talk with smart glass companies every single week, and they ask us questions like, could you have an employee log onto a smart glass device and then dynamically present to them the menu, the navigation system, the icons they're allowed to see, the icons that they're not allowed to see, all based on a policy that's up on your server. So immediately, dynamically, when they log into the device, give them that unique user experience. And that's like an example of something we do that a traditional MDM would never do. I think we're qualified, this panel, to talk about this subject. Augmate is currently working on one of the largest smart glass deployments in history, so several thousand devices out in the field. And I think our panel is even more qualified because they're implementing wearable technology and IoT at their particular companies. So I'm just going to run through their names real quick, but then I'll let them introduce themselves. So in no particular order here, well, I guess I will go in order. We've got John Simmons, the technical executive at EPRI. EPRI is the Electrical Power Resource Research Institute. Next, we have Hameed Montessori, who's the VP of Software Engineering at Stanley Black Decker. Next to him, we've got Brian Laughlin, the technical fellow at Boeing, who works on a lot of their strategic architecture plans. Next to him, we've got Michael Newsome, who's in charge of global learning systems at Bayer, which was, I believe his company was acquired, it was Montessori. And then finally, we've got Scott Aldridge, who is the disruptive innovations leader at CDM Smith. So maybe what we could do is you could talk about either what you're working on that's particular to this subject at your company, and just really quickly as an introduction.
Sure. Again, I'm John Simmons. I'm a technical executive, not the technical executive. There's a bunch of us. At the Electric Power Research Institute, we're a research company that does research into providing the public with safer, cheaper, more reliable, more environmentally sustainable power. And so we are looking at AR with those goals in mind. So we look at aspects like worker safety and making workers more efficient so they can get the power back on and serve the public better.
So hello, Hameed Montessori. I work for Stanley Black Decker. Stanley Black Decker is about a 175-year-old company organized around 3 business units. The first business unit that most people know us with regards to is global tools and storage. We're #1 tool manufacturer in the world. Have brands that start from do-it-yourselfers in a Stanley Black Decker all the way to DeWalt for professional. A lot of things in the middle, including Craftsman that we kind of salvaged from a retailer about a year and a half ago. And because of that, we have a lot of things that are used in many industries like construction. Obviously, those things are natural to being connected together, being IoT enabled. We have a lot of factories that manufacture those. We also have billion-dollar plus business units that look at infrastructure, things like oil and gas, engineering fastening that goes into the cars or electronic devices, and things of that type. And also, we are number 2 in the world in commercial electronic security, providing electronic security and also security in the world of healthcare, including my favorite brand, Hugs, that secures newly born infants against theft. And all of these things have a lot of IoT components to them. My group is called the Digital Accelerator. We're focused a little bit into the future. And of course, hand in hand with IoT is a lot of wearable technology. We started by looking at remote SME applications, going into virtual reality and the applications in various connected workplaces that we probably would get to talk about. So it's a pleasure to be here.
Okay.
I'm Brian Laughlin, IT architect and technical fellow for the Boeing company. We just had our centennial birthday, so that's pretty cool, about a year ago. Not very many companies left that reached the 100-year mark. Kind of proud of that. We're the #1 export for the U.S. We have a commercial and a military sides of the house, and then as well as a Boeing Global Services group that we just stood up that's going to start producing services for the aerospace industry, such as gate maintenance and training and things like that. The term augmented reality was actually coined at Boeing back in the early 90s. Not a lot of people know that, but so we have quite a rich heritage with augmented reality and kind of emerging technologies. As you can imagine, with all the airplanes that we build and service and all the different kind of things we do around the world, being able to communicate and to provide point of use and time of need information is of critical import for the company. So a lot of the work that we're doing is figuring out how to make these different emerging technology silos conversant, which is right in the domain of Industry 4.0. So, thank you.
I'm Mike Newsome, originally from Monsanto. So spent about 6 years at Monsanto, and as of 4 weeks ago now, a new employee of Bayer. So Monsanto did make it to the 100-year mark, Ryan, and now part of an organization that is 150 years. So nice. Part of our transformation has really been a focus on science, right? So really innovative technologies when it comes to seed and selling those seeds to our farmers. And then several years ago, we started to shift into a little bit more customer-centric approach and helping our farmers make decisions. So part of that came with collecting data from our farmers and also providing analytics back to our farmers. So today, through a platform called Science at Scale, which is an IoT platform, we capture data from our fields regarding performance of seeds, disease and insect pressures, and use that information to provide insights to farmers on their space. So my role as Global Learning Systems and Development Lead is really driving the workforce to digital transformation. So making sure our workforce is up to speed with the trends, shifting our skill sets where they're needed, and then also incorporating some of these opportunities ourselves. So can we provide real-time learning opportunities to our employees across the globe?
Wow, impressive. So I'm Scott Aldridge with CDM Smith. We're a 71-year-old private engineering construction firm out of Boston. And we build infrastructure in the transportation, utilities, federal, industrial, all over the world. Our bread and butter, I would say, is probably water, wastewater. And we're targeting the use of wearable devices and IoT devices in very not as widespread as these guys, more targeted so that we're picking and choosing where we're doing it right now. And we're starting to incorporate it into our design work and educating, quite frankly, our engineers in how to ensure that they're future-proofing our designs by designing with IoT and visualization in mind.
Okay, awesome. So thank you so much for joining the panel, and kudos to BrainXchange for picking a real winning team here. So what I'll do is I'll talk through the description of this panel discussion, and so you get a sense of the context and how it fits into the larger picture. So this discussion today, it will discuss everything from video, still images, audio recordings, and location-based information machine and environmental data, and even biometrics wearables data that have the potential to generate and transmit loads of valuable data to the enterprise. In this group discussion, enterprises will consider how wearable and other sensor data can be intelligently analyzed and enhance business processes. So in addition to that, it'll be addressing some of the challenges of data collection, storage, and analysis. And the panel will take a broader look at some of the other technologies like drones, robotics, even artificial intelligence to create a truly connected workplace. So that's a really big topic. The future is here, and these folks will definitely be able to talk about it. So the very first question that we have for the panel is, what role will wearable technology play in the fourth industrial revolution? And whoever feels compelled to begin, and I don't know if we'll be able to get every person on every question, because it's we got about 1 hour and it's five panelists, but if you feel compelled to add something, definitely jump in.
Well, I wish I had a recording of, we discussed this at lunch, and we had a really great conversation, and of which I didn't contribute at all, but I'll try and give a little synopsis. There's a tremendous amount of data that's either available or could be available with the right sensing technology or the right environment. And the way I see it is that people in the factory of the future are going to be so plugged in to their environment that they're going to be able to predict what is occurring and make remediation way before it becomes a problem. For instance, if it's a pressing operation and the thickness tolerance starts to creep up, and some sensor senses that, and it also senses that this part of the press is warm, and it deduces that a bearing is wearing irregularly and is about to go, and it is heating up, and therefore the press isn't pressing as hard. Well, it can make all of those assessments and say, Pete, go look at press number 16 and swap out this bearing. And that's the kind of thing that will be enabled as this predictive environment will be proactive rather than reactive, and hopefully we'll get a lot more out of our production facilities.
So to add to what John was saying, we're looking at 5 distinct applications for wearables and IoT within Industry 4.0. The number one that a lot of other people are looking at is this remote subject matter expert. So if you have a problem or you have sent somebody to install something, there is help available through maybe smart glasses for the person to kind of work his or her way through the equipment. A second application is, of course, worker safety. If you look at places like construction, there are many holes here and there that could be dangerous to people. So if you have wearables, you can monitor the signs, the vital signs, and see where they are. A third one would be applications related to productivity, where there is kind of training through augmented reality, extended reality, and things like that, where the workforce could be sort of equipped with knowledge better in a more concrete way. A fourth one is monitoring, and a lot of times, as John was saying, there is important things that are happening on the factory floor, and there are people who have to make decisions. If they get the information, if everything is IoT enabled, if they get the information at the right time, regardless of where they are. So a lot of times wearables are great ways to kind of inform them that something has happened. And the fifth one is to kind of visualize a design for the future, and maybe through a virtual reality operate within that environment and see if some of the designs and products that people have come up with would actually work properly there or not. That's some of the things we're seeing.
Cool. Is anybody out here, show of hands, familiar with Ray Kurzweil? Singularity? See a few hands popping up? Okay. So I think we're seeing what Ray Kurzweil had predicted, where you're going to see the convergence of man and machine and data, and all these things are going to come together into a common stream. I think that's where the future of wearables and these technologies is going to take us. I think we're beginning to see the promise fulfilled that we've held dear for a very long time, that computers would actually assist us Heretofore, they've just been so many dumb tools or screwdrivers, wrenches, type of thing that we had to manually operate and engage with. I think very quickly, as we become smarter about doing this and quit serving the tools that we've created to help us out, that we're going to start to have them assisting us as a partner, in the kind of businesses that we perform. So I think we're going to be able to provide point of use and time of need information based on contextual cues that will help us to know exactly what kind of tools and information and different kind of things we need to provide to the individual at that location to assure success in getting the mission accomplished that they're trying to complete. And I think we're going to start to see the lines blur between man and machine and kind of cognition. We had a really great keynote presentation this morning. I love the way that he characterized about kind of projecting our minds out into the world and the environment. And I think that's exactly right and where this is all going to take us in the future.
Yeah, so I think spot on with insights, so providing insights to people throughout their day, right? And a big piece that is of interest to me right now, so a lot of new information is coming out about neuroscience and really people's limitations, right? So can people really multitask? Well, science says about 2.5% of people can actually do that, which isn't a lot. And as I was listening to that podcast, my wife pointed out that I missed my exit on the highway. So proof in point that is not a possibility. But in addition to that, just some cognitive limitations to the human brain. And I think one other example of that is the Yanny Versaloral. Anybody familiar with that? Basically, for me, that opened up, my reality can be different from someone else's reality. And I think a case in point on that for me was an argument I had with my mom a couple weeks ago, and asked my wife's perspective, told her my mom's point of view and my point of view. And at the end of it, she said, "You're both right, and you're both stubborn," which was something for me as self-actualization and awareness is also a limitation of humans today, right? Only 10 to 15% of humans are actually self-aware of how they present themselves, how they act in certain environments. So if we can start to expose some of those insights and make people cognizant of those things as they go throughout their day and leverage other resources or get better at doing some of those things, I think that's what we think about when we think about enhancement of the workforce or the human within their environment.
So real quickly, I agree that wearables are going to play a very important role in how work gets done in the future. I would say that right now, after talking to our clients and showing them actually some demonstrations of where we think it's going to go, they said that's fantastic, but we need to get some of this lower hanging fruit out of the way. So we've kind of backed off some of our grander plans to help address two major issues in the clients that we serve, which is an aging infrastructure and an aging workforce. So that's primarily where we've focused our work so far. I would say in the next few years, we will certainly get to these broader visions.
Great. So when we think about the connected workforce, there's a huge component that has to do with data. And so I'm curious the panel's thoughts about data collection, data analytics, data accuracy, and also data security. And so how does that play? What are some of the best practices and some of the challenges in all those things?
So one of the things that I can say is, especially a company that has grown quite a bit organically, but also has acquired a number of companies, is that there is a dichotomy and multiplicity of truth that starts showing up within the companies. And one of the best practices to kind of help bring all of that under control, and it could really be going out of control if you end up having hundreds of thousands of SKUs and things of that nature, is to create sort of a data lake for the company where the data can come in and a lot of good data scientists can go and do experiment with their algorithms and come up with facts of value for the business. And the concept of data lake is well known. A lot of people work on it. It so turns out that it's kind of particularly difficult if you have a lot of disparate systems to kind of connect them together to create a data lake where you can actually find useful facts that would help the business and solve some of the business problems. So coming up with a reliable, credible data lake that is used by all types of business people is one of the key enablers that we have found in our business.
So I think relative to data collection and whatnot, we had a really interesting discussion. We were talking about, do you approach it from an R&D type perspective where you're kind of doing exploratory things, and I talked a little bit more about how we use a kind of applied innovation, so we have a specific task that we're trying to accomplish. I think the answer is really an also and, not an either or. One of the things that I think is largely missing in industry is we pay a lot of attention to the headsets and the computers and the devices and the bits and bytes and all the physical accoutrements, but we don't think about schemas and taxonomies and ontologies and information architecture, and how do we create smart data so that it can be retrieved easily, and how do we handle things like duplicity, and how do we do things like data at the edge, where we cleanse the data before we send it back to be processed, and it's kind of a wide open space. Boeing has made a very large investment in this space. We really believe in this. We have a company called Analytics for Boeing, and so we have a lot of data scientists, and we're doing a lot of work in this area. But I think that the big thing is going to be, how do you get garbage in, garbage out? How do you get clean data, and how do you turn that data into information? I think there's a really good quote that I believe, I'm trying to think who said it, but they talked about, don't be a drip, that you're data rich and information poor. I think that's a really good quote. I love that acronym. So I think those are some of the things that we're facing and issues that we're going to need to address here directly shortly.
Yeah, part of our journey was actually democratizing our data across the company, right? So everybody had data. Most people weren't sharing their data and didn't want to give other people access to their data. So the first thing we had to do was break down those barriers. And part of that was forming a data science council to basically serve as a center of excellence to help break down those walls, compile that data, and understand what analytics and decisions we can pull from some of the data we are capturing. But that's still a journey in progress today.
Awesome. So this next question, maybe even a little bit selfish in nature, that I'm just really curious from the panel. When we were researching our IoT platform, there's some statistics out there that talk about devices and sensors and just the sheer volume of them over the next few years. And some of the numbers, they're staggering. It's in the order of magnitude of like 50 billion devices by 2020, 250 billion devices by 2025, and 1 trillion devices within 20 years. So that's all IoT devices. So essentially, every piece of equipment or appliance or device, anything that you plug in, that's electric, will be connected to the internet. So it does beg the question. So just piggybacking off of this last question that had to do with data collection and data analytics and all that kind of thing, there's the potential for data overload, right? And so there's going to be so much information, you start saying to yourself, do you need an artificial intelligence layer on top of this just to interpret the data or do things? And what's the thought process on that, and having all this data, and what does it mean, and how do we process it? What do we do with it?
Let me just give you some numbers. Once upon a time, does anybody remember getting an electric bill? Okay, nobody, good. It used to be that, a guy would come out every month and read your meter. So that was one reading per month. Now, if you have a smart meter, they typically read the meter every 15 minutes. So that's like 178,000% more data than the once a month reading. And in that data, there's a tremendous amount of information. You can tell if, and I'm going to have a little jargon here, you can tell what transformer your meter is connected to, you can tell which phase your house is connected to. You can tell if you're stealing power or if you're growing marijuana in your basement. It goes on and on. But you have to be able to process that data. And we're only talking about every 15-minute data. If we were to actually, the meter takes, I don't know, hundreds of readings per second. And it uses that and averages them for that 15-minute reading. If you were to dig into that, there'd be even more information that would be available. So Pete hit the nail on the head. I think as we generate more and more data, and your typical utility has several million meters. So as we have this avalanche of data coming in, there's going to have to be some sort of machine learning or artificial intelligence or convolutional neural network or some sort of processing before we actually start looking at the data, because it's literally impossible for a human to wrap their heads around all this data. So out of all that data, if you're going to write something down, write this down. Everything I need to know about augmented reality, I can learn by watching football. Okay? If you watch a football game, your interface shows you the line of scrimmage, the first down line, which way they're going, how many yards they go, and it does it in a way that doesn't detract from the game. If you remember, it used to be that you would get this frame around your TV and it would have the downs and all the information, and you would lose probably a good third of the screen. But with augmented reality, you can actually see what's going on, and you can see the information, because there's a ton of data that you could be seeing, but you're seeing the information you need to know about without losing sight of the context, the real reason you're watching TV. And so that's where we got to go with this, is being able to present information instead of a bazillion points of data. What do you need to know, and when do you need to know it?
So following up on that discussion, and something that Brian also talked about, having a lot of data and no information to get into actually getting information out of the data. I would say the mass of data is definitely a problem in the industrial world. There are typically two categories of products we deal with. And one is kind of individual products that are connected, so they can send data about their rate of revolution, the state of charge, and things of that nature. And then you have the whole workplace that is connected. And so within the world of IoT, a lot of times data goes to the cloud, but a very important concept is the edge compute. So a lot of times you have edge nodes within factories or other places that that run IoT applications at the edge. And in fact, a lot of the cloud providers have started providing edge nodes for their cloud IoT systems. And the deal about an edge node that is very important is that it typically has the capacity to get the data from the devices it's connected to and actually detect whether it needs to send deltas up to the cloud or not. So a lot of times the data that you don't need that can potentially overwhelm your storage or increase the cost of storage significantly in the cloud, it could be filtered at the edge, and so you actually get a summarized type of data that comes through. So edge compute, or as Cisco calls it, fog compute, has become a very important part of IoT systems, and one of the tools in dealing with the avalanche of data, even before you start looking at processing it in appropriate ways that was talked about.
So I think the ubiquity and the cheapness with which we can collect data and process it, like we've talked about, is going to create this kind of tsunami wave, crushing wave of data. And it's going to require us to rethink what we do with data. Fortunately, we have models in the way that we naturally learn. Think about, for those of you that can drive a stick shift, and it sounds like the numbers are dwindling by the day. When you first learned how to drive a car, driving a stick shift was really difficult because you had to push in on the clutch and you had to shift the gear and you had all these things you had to coordinate. But as you got better and smarter and all these kind of things, you began to automate a lot of these processes, and you started figuring out what were the key points that you needed to attend to. And I think in the same way, as we maybe initially have a phase of kind of exploratory where we kind of collect everything and then see what patterns emerge, so we begin to understand what's happening and what to look for, that we'll start to figure out ways to look at what's changed. Because a lot of times we don't really care about all the individual points of data. What I need to know is when something changes and what direction that change occurred. So I think it's going to require that we think differently about how we use data, what we do with it, and to be a little bit smarter about how we strategize the applications of that. But again, I think if we pay attention to how we naturally learn, that we have a lot of models in kind of nature and how we do that anyway. So just something that occurred to me as we were talking about that, how are we going to address that? Because this is going to be an exponentially growing, crush. In the last 2 years, 90% of the data has been created. So what's that going to look like in the next 6 months? I mean, it's at an accelerating rate. So it's definitely something we're going to have to handle. And I think we need to maybe start putting some thoughts about how we're going to address that. And I don't think technology is always the answer. I think maybe strategy might help us out.
Luckily for me, I never had to learn to drive a stick. And luckily for me also, in my role, I shouldn't have to deal with this problem as far as too much data. That'll be something our Data Science Council looks like. But one of the things we did proactively to make sure we were looking at the right data across the business was when we started forming the Data Science Council, we actually looked to our business and talent within the business to identify people that had strong data skills already and groom them into data science roles so that they have knowledge of the business already, they have a strong understanding of where the business is going and what data will help drive those parts of the business. So within that council today, there's representation for knowledge across all of those business functions, which ultimately, hopefully, we'll start collecting the right data for our business to cut down on that issue.
Again, real quickly, I don't want to say too much because these guys have said a lot and it's all accurate. I will just say that our clients collect a lot of data with their SCADA systems and other systems and the infrastructure that we build, and what we're finding is that they're not using very much of it at all. And so we're trying to find out which data is going to provide the best business case for improving their processes and target how to capture and utilize that data. And we're still in the process of doing that. We've actually come up with a few different scenarios for different clients to capture certain data and do certain things, but it's, again, very targeted.
And that's the one thing that needs to be stressed is there can be a huge differential in time constants for data. You could be collecting data in some sort of a sensor 10,000 times a second, and you're out there and you check on a piece of equipment every 6 months, and your way of knowing that maybe there's something wrong with this piece of equipment is something that's happening at 100,000 times a second. So there's a tremendous variability in the rates of data, and trying to establish correlations between causes and effects when that time constant can be so variable is a very, very difficult thing to do, because I've tried.
Yeah, I think making data actionable is super important, but there's so much data, it's really difficult. Mike had a great story that he was talking about. We were talking about wearables, over lunch, obviously, as we're, getting ready for this. And he was talking about wearables for plants. And this was during his time at Monsanto. And, we think about wearables for humans, but did anyone ever give thought to wearables for plants? But then the kind of data that they were collecting was so important to the plants, and it meant so much to agriculture that it was just really interesting. But in the spirit of time, let me just keep moving here. So the next question has to do with the analytics of wearables with optimizing processes. So, for example, the way I think about this is even something like fatigue, right? So if you've got wearables that are on a human, whether it's heartbeat or some of the smart glasses allow you either through eye tracking or the gyroscope or accelerometer, head nods, if someone was driving, that kind of thing, would detect if someone was sleepy or about ready to make a mistake or drive off the road, or they're operating, dangerous equipment, and there's consequences to operating that kind of thing when you're tired. And that's just one example, but what are your thoughts on how wearables, and how can we optimize processes based on wearables?
Yeah, that human element, especially right now, I think is important. So we're at a time when we have arguably one of the most visionary figures in technology tweeting on Ambien in the middle of the night and seemingly out of control, right, in some ways. And this is someone who's super intelligent. So our ability, and this is where we start talking about our human limitations, to recognize that and be self-aware of that is an issue right now. And that's something people, at least within our organization, are our greatest asset. And that's the shift we haven't seen yet in technology, and that's where I expect it to move to next, is really understanding our cognitive ability, where we're at right now, our ability to make decisions, and our ability to recognize when we shouldn't make a decision. So I think that is a huge opportunity, and will have a massive impact on the workforce and how we operate when we get there. But there's some work to do, I think.
A lot of times, wearables are looked upon as gathering data with regards to the person who's wearing the wearables. But there are some interesting applications where the wearable is used to actually gather data about the environment independent of the person that is wearing it. So an example of it is that, let's say you want to collect information about progress of a construction environment, and you don't want to spend the money that is required in order to hire people. There's a shortage of workers in the construction world to go around and capture data. So you can instrument the workers with cheap cameras to kind of gather information from the construction world. And if you do certain things right, maybe through the magic of computational geometry, you can even create a three-dimensional view of the world that they are in as they move around with their camera, which could be very helpful in doing a lot of things, including monitoring the progress of the construction and things like that. So in situations like that, interestingly, every bit of information that the wearable gathers from the environment is of value, because it could be analyzed in order to identify the changes in the environment that is important for monitoring the progress. So that's an application that a lot of times is not looked upon, that it's very, very beneficial in how the wearables can indirectly help with something that is not related to the person who wears that wearable device.
Yeah, no, something that we look at from a health and well-being standpoint. We use an app called Limeade that can connect to your personal wearable devices, that captures health information and provides incentives that the company gives to you to stay healthy, to exercise 3 times a week, to learn about sleep and how important it is across the business. So I think that's our entry level into being more health conscious and more well-being focused on employees. But I think there's opportunities to get better and grow.
We have a program at Boeing called Boeing on the Move, and we actually incentivize employees. We give them I think it's a $100 voucher or something to get a smartwatch or a smart type device that will monitor their sleep and help. Same thing, type deal. So it's good to hear that. So I think there's going to be not only the optimization of helping folks know where they're at in terms of health or readiness. Are you drowsy? Are you sick? Are there issues that are going on? To keep the person safe. I think we'll also use kind of IoT and wearable type technologies to help us understand, how to most efficiently deploy resources. So is there a doctor in the house, kind of thing, whoever is the certified to perform some kind of a task and is closest to the locale, perhaps we deploy them or dynamically, reassign these kind of people based on the ebb and flow of where folks happen to be going. I think also that, we'll start to look at these patterns and learn, about kind of inefficiencies in movement and flow through factories and things. I don't know if you guys, the stuff that Peggy was showing earlier, that's called a spaghetti chart, where she had all the little squiggles that showed where people were going, and it warms the cockles of my heart as an old lean guy to see that kind of stuff and to hear the word tack time. It's pretty cool. But so you guys noticed how effective it was to see the stark contrast in the video between 2 different conditions. And it's an old trick we use in usability. We can sit there and argue about this all day long, but when I show you video footage of somebody not being able to use your interface, it's pretty hard to refute that. So I think that that's going to be a really powerful way for us to use IoT and these emerging technologies, is to be able to analyze and understand the flow of product and processes and things like that, and to be able to continually improve things without having to be invasive and make deliberate kind of schedule disrupting type of workshops and things like that in order to achieve the same type of objectives.
Cool.
Yeah, and that's a good point. I think the other thing to add to that is and exactly that point, the question that we push to our organization to kind of shift towards a digital culture is, do you have data to support that? Because you're right, oftentimes you'll hear somebody throw out something factual without data to support it. And it's based on an observation, and there's several ways that goes wrong. But if there's data, or you can go get data, that's the way to do it. I think one interesting piece, sorry if you had something else, Pete, that just listening to the discussions today, and when we think about all of this technology and where it goes and how do you determine where to start and what your opportunities are, I think the one piece that I haven't heard talked about a ton is, if you don't step into the space and start to learn about it and start to experiment in it, what's the opportunity you lose, right? So what's the cost to not staying in tune or not identifying something that you can improve upon? And I think that's something we all need to look at as we explore some of these new capabilities, is also, if we don't step into the space, what will our competition do if they do step into the space? And let's use that as a measure as well.
So I'm going to combine the next two questions. One is about advice to deploying wearables and using the analytics of the wearables. So advice to a company who, let's say they're starting from square one, they haven't done it before. What are some of the things to consider or think about? And then the other question was about the same thing, but for IoT. And so when I think about that, as far as the panel goes, I think about Scott, for one, because he works with HoloLens and CAD models, and it's very important to, from a planning perspective, to incorporate that. And I also think about Brian from a strategy and planning perspective, how important it is to say, we want to design this correctly from the beginning. So the question is, what advice would you give to a company that was looking to deploy wearables or deploy some sort of IoT environment? What are some of the considerations and things to think about?
From my point of view, have it based on a client need, have it based on an actual outcome that you're trying to achieve. Technology is fantastic. The HoloLens is great. The next one that's coming out, I'm very excited about some of the new capabilities with the new Connect sensor inside there. If you've seen any of the videos of how that's going to work, that's pretty impressive. But base it on an actual use case to achieve a goal. And, there are lots of different devices out there, IoT and wearables. Give them all a try. Take your time and figure out what's going to fit your needs. When we decided on the HoloLens, I was just about to pick a smart glass. I had been going through an evaluation of several different brands, but when we saw that we could visualize our 3D content in the real world, it was a no-brainer for us, because everything we do is built around creating a 3D model of whatever we're going to build or design. So it was just a perfect use case for us.
Scott, I think we're right there, buddy. I'm with you. In fact, I don't think you can overemphasize know what it is you're trying to accomplish. Is anybody in the audience, are you guys familiar with a book called Start With Why by a guy named Simon Sinek? Show of hands. Simon? Yeah, pretty neat guy. So if you don't do anything but watch the TED Talk, it's easily 18 of the best minutes you'll ever spend on watching anything related to business. He posits that we have this concept of the golden rings, the golden circles, and the center one is your why. He posits that great leaders and great companies alike, they have a core mission, and they know what they're trying to achieve. And then around that is a larger ring, and that is your how. So those are the objectives. So you could think about Kodak, for example. Kodak, their original why was, how do I capture this moment in time? And so that's how I would characterize that. And then their how was the photographic procedures and techniques and that type of stuff. And then the what became the chemicals and the cameras, right? So this is kind of a bullseye type stack up. The problem that companies have is over time they begin to forget about what their why was, their original why, and they begin to identify with their what. You would see this if I went out and said, well, what's Boeing? A lot of times I get, well, it's an airplane company. Boeing's not an airplane company. Boeing is a connection company. How we connect people and places to coalesce in a time things and people to coalesce in a time and place is we use aerospace technology, and then the what would be the airplanes that we sell. But if we for a moment let ourselves relax and forget what our core why is, then we run the same risk that Kodak did, who invented a lot of the photographic processes. When they thought that the rest of the world went digital, they thought they were still a photographic company. So in accord, what I would suggest to companies that are trying to embark down this technology path is, first of all, the big head fake is it's never about technology. I'll say it again, it's really important that we understand this. It's not about technology. Nobody who ever bought a drill wanted a drill, they needed a hole, okay? We gotta know that. What is your core objective? What's the soul of the intention? And then once you understand what that soul intention is, then let's figure out what's the best business practice to help us get there and focus on that process. Once you get that done, value stream map that thing out, then you wanna wire brush that and simulate it and make sure that you cut all the steps. And then every step in that process has to adhere to at least 3 steps of a litmus. It has to be value added in terms of something a customer would pay for. It has to be done right the first time, every time. And it has to transform the form, fit, or function. If it doesn't do all 3 of those, it can't be value added. You want to get rid of all the non-value adds immediately, and there'll be a few non-value but necessaries, and you have to keep those because they set you up for your value add step, the next stage. Then you go back and you say, okay, with IT technologies, how do I streamline this? Well, the neat thing about IT is we can simultaneously do a lot of informational type process. So you can absolutely crush your attack time and minimize it, make it really, really small, fast as it can be. Then and only then you want to turn to technology and say what will control, accelerate, and or distribute those information processes. And if you will do that faithfully every time, and it's a painful process because it requires homework. It takes a lot of heavy lifting to do these things, and it's not a lot of fun. It's not as sexy as going out and picking up a HoloLens and playing with it. I'm a technophile, I love that stuff. But if you will dutifully do your homework in that way, I can almost guarantee you success every time. And you don't do things to your user, your end user, you do them with your end user. Not 2 or 4. Really, really important because you've got to have that buy-in. And if you'll go through that process and work with the end user to develop their solution, not yours, it's pretty amazing what that can offer us in terms of a force multiplier.
What he said.
Awesome. It does appear that we are out of time, so I'd like to thank my distinguished panel. I thought it was really informative. Big round of applause. Thank you so much.